In this webinar, we will look at the following: an introduction to Sheet Metal CAD, an introduction to the SFX database, creating sheet metal parts from simple 2D geometry, creating a part from open profiles, and creating a part from solids. We will look at how to design non-rectangular flanges and converting solid models to sheet metal models. We will look at setting part properties and unfolding, and sending a part to RADAN CAM. We will also have a closer look at corner relief, flange offset, and other commands. And finally, we'll have a look at working with assemblies. Introducing SFX. SFX is a database from Hexagon that manages your manufacturing assets, including materials, bending data, and bending tools. Designer sheet metal unfolding is very accurate. This accuracy can be further enhanced by using the SFX database. When unfolding in Designer, reference can be made to your specific materials bending data and your preferred press brake tooling. This ensures highly accurate flat blank developments of both imported and designed parts. Here in Designer, you can see I have a sheet metal component that I wish to unfold. If I go to my Set Part Properties option, I've got various methods I can use to unfold this particular component. If I go to my Design Parameters under the Manual option, I can manually type in a K-factor, a setback, or a DIN correction. If I go to Tool-Based Results, I can manually type in a V-width, which will give me the correct developed blank based on the V that I wish to use when bending. If I go to my Use Database option, then Designer will reference the database of my particular materials and my preferred bending tools in order to create an accurate developed blank of this component. And there you can see my developed blank of this particular component. So here is a part, an example part that we might have sent to us. So let's start with that one. So what I'm going to do is I'm going to come into here and I'm going to start my Designer. Now Designer will import a whole range of files. So I'm going to open a file. I'm going to set my filter. You can see all the file types that I can bring in here, but I'm going to be looking for an ASYS SAP file. And so we're going to take this bracket and bring it in to Designer. So as I say, Designer is incredibly good at bringing in all sorts of different file types. So there is my sheet metal bracket. So I'm in Designer. I can get various views of this part by simply selecting the view options here. Okay, now you see we're in Designer. There is a sheet metal tab. So those of you that have the sheet metal element of Designer, you will already have this tab, but this can be added to a standard Designer to give you the sheet metal commands that you can see here. So working our way across, we can set our properties. This is our unfold button. We can edit bend radiuses and splits. We can manipulate thicknesses. We can move flanges and change flange angles. We can add corner reliefs. We can split edges, add bends, split faces. There's a whole range of commands, and I'll try and work through those as we go through. So the first thing I'm going to do for this imported model, now bear in mind that this was a SAP file, I'm simply going to select the face that I want to be uppermost, and I've given it some material definition. Okay, and I've told it how I'd like to unfold it. So if I now go back to my Sheet Metal tab, I can unfold this part as easily as that. So that was an imported SAT file, which I've now unfolded. But the beauty of Designer Sheet Metal is that you can manipulate this. So using a simple move flange option, I can pick up on this flange and I can simply drag that flange. Now, again, I just reiterate, this is in an imported model. So there's no sheet metal intelligence in there. I've simply imported it from another CAD system. If I want to move a second flange, I can do that. But if I want to make that flange the same height as this flange, I can simply snap to that location, and I've now got those two flanges at the same height. If I wanted maybe to change a flange angle, I come into here and I've got an option to change flange angle. I click on here. Now I can grab that and simply move it, or I can type a dimension in here. I'm just using my middle mouse button as I speak, and I'm just simply rolling the middle mouse button to specify the angle that I want that flange to be. Okay, so if I accept that and I come back to see my isometric view, I can simply change the material thickness. So having specified a face to unfold, the software will now thicken that model based on the direction that I selected. So you can see there, we've gone from a 3mm thick model to a 6mm thick and then back again. Okay, I won't dwell with this model much longer. There's a couple of nice things you can do here though. Say for example that I wanted to make this tab a bit longer. I can do that with sheet metal commands, or I can do that with designer solid modeling commands. So I can simply use a move command and I can window around the elements that I want to move. So let's come in here and say that what we want to do is move some elements. If I come in and we'll say we're going to move, let's pick on a face. Oh, I tell you what I'll do. So I've picked the elements I want to move. I can simply just drag them now. It's a very simple case of dragging. I can use a dimension if I wish. So I can type in 20mm there, and I've actually moved that flange. So again, just reiterating, this is an imported model from another CAD system. Okay. If I wanted to maybe do a mod on multiple items, I can simply get a view on the side of my model, and I could say that what I want to do is a move. And then if I come in here and we window around those items, I'm actually moving. If I just rotate, you can see I'm moving both of those tabs because I've picked up both of those in my selection. And finally, if I just want to make this look a bit sexier, I can simply come into my materials option. I've got a range of different materials. I go to my metal material and I'm going to window around my part and I'm going to make that silver. So you can see here that if I zoom in, I've got a nice shiny texture on my model. And then finally, I can go back to my sheet metal and I can do a final unfold to see what I've got in terms of my development. So that was importing a simple file. Let's come back to my PowerPoint and see what we're going to do here. Okay, so what we're going to do now is we're going to show you how we can create a part from simple 2D geometry. So that's the part that I'm looking to create. Okay, so I'll just come over here and we'll start a brand new session. Okay, so again, I'm in Designer. If I go to my wireframe option, I'm going to create a rectangle and I'm going to do that out here. So I'm going to make this rectangle 300 by 200, like so, and then we'll do something similar again. And this time we'll say it's going to be 200 by 300. Okay. Now you'll see that if I toggle this, I've got regions. So in Designer, it will find closed regions. So that shape is closed into much that I could use that to create a part. So if I go into my sheet metal and I say create a part, I can now pick these regions. If I go multi, I can pick all of these regions to create a part. And if I accept that and say, now, you can see here the direction of the thickness. So the thickness is going down. And if I come into my material properties here, I'll just drag this over slightly so you can see what's happening. I've got various different types of material that I can select. Now, there are 3 default types that are available. You've got aluminium, stainless steel, and steel. And against those, you can set the method of unfold. So in this case, I'm going to say that I want to unfold this with a K factor of 0.445. Now, if I accept this, you'll see that it's created a sheet metal element, but it's got lots of different parts. So if I go to my layers and I expand this out, you'll see that what I've done is I've created 5 separate solids. So that's not a great idea when you're going to create lots of different components. So I'm just going to hit the undo here. And this is a little tip for creating sheet metal parts. If you're going to draw geometry, make sure it's a single closed profile. So what I'm going to do here is I'm just going to trim out the elements that I don't want, making that, and then I'm going to create me a sheet metal part from this single element. Now, by doing that, I will now have just a single solid instead of 5 separate solids. So again, I've set my material thickness. I've set my inner bend radius. I've got my selection of material, and I've specified the unfold method. So if I select that, I've now got my sheet metal component. Right, so what I want to do now is just add a few elements to this. So back to my sheet metal tab, and I'm going to use the option to add a flange. Now, depending on where you pick this model, it specifies the direction of the flange. So if I pick the top edge, the flange will go up. Okay. If I pick the bottom edge, the flange will go down. Now you can toggle it once you've selected. You can simply use this reverse side option, which will toggle the direction of the flange. Now, once I've added the flange, I can simply stretch it out so I can make it deeper. I can change the angle if I want it to be a different angle. Again, you can do this via typing a dimension. So I'm going to put it back to 90, and I want this to be 50 mil deep. So I'm going to come around the other side. Again, I'm going to select the bottom of my material thickness so that the flange goes down, and I'm going to accept that. We'll put a flange out here, and then we'll put a flange out here. If I want to maybe add a flange at an angle, again, I can simply select the top edge. I can angle that back. In this case, I'm going to say I want it to be 45 degrees, and then I'm going to slide this up, and we're going to make this one 70 mil. And then we'll put another flange out here. Now, because of the angle, it remembers the angle. So we've now got a flange that's parallel to this face. So I'm going to accept this, and then I'm going to place a flange on the top edge. I want that flange to be 90. And I'm going to bring it up here. And then finally, I'll put a flange out here like so. Now, at any stage, you can check to see what it looks like unfolded. So we can simply toggle the unfold very quickly and very easily. Now, I've put that flange up there. If I want that flange to be the same height as this one, so if I come in on a side view, you can see that that flange is much higher than that. So using my move flange option, I can simply drag this down, but then snap to that point there. So we've now specified the height of that to be the height of this flange so that they are now in line. What I'm going to do is I want to add some holes on here. So I'm going to come in here with my wireframe. I'm going to work on this plane here. So I'm going to put a circle on. And what I want to do is make sure I've got my smart select on. And then I'm going to find the center of that flange vertically and the center of that flange horizontally. And where the two meet, I'm going to drag out and put a 20 diameter hole in there. Sorry. Let's do that. Okay, and then in my sheet metal commands, I've got a cut flange option. And by simply pointing to the geometry, I can cut the flange, cut the hole in the flange. Now I'll very quickly do a rectangle here, like so. And I will also do a circle. So whereas when I'm creating the model, I don't, to the first flange, I don't want intersecting geometry, but when you're cutting holes, it doesn't matter. So if I go to my sheet metal and I go cut flange and I window round all of that geometry, I've now cut a hole in that flange like so. I'll do one more hole in here because time is marching on very rapidly. So I'm going to go to my unfold. And then I'm going to go to wireframe. And what I want to do is I want to put a hole which is measured off the center of this bend. So if I come in here and I say I want to put a hole which is centrally from that point to that point, and we're going to say we want that to be 10. Okay, so we've actually put this on the developed blank. So if I go back to my sheet metal and I say cut flange like so, I've cut it in the blank, but if I now fold that back up, then that hole is positioned off a theoretical center of this bend in here. Okay. So there's my completed part. So I must move on. I'm going to bring back my PowerPoint and then we'll have a look at what we're going to do next. Okay. Right. What I want to do is talk in a bit more detail about how we set the bend, the unfold method, and the bend relief. So to do that, I'm just going to draw a very simple component. So again, bear with me whilst I draw this very simple model. So I'm going to go to a new designer session. I'm going to go to wireframe and draw a very simple rectangle. It is 200 by 100, like so. When I again create a part, I get the option to choose the rectangle. Now again, the arrow is going down, so the thickness is going down. I've got 3 mil thick, so there's my thickness. I've got a material definition. I can go for stainless steel on this occasion. This distance, don't worry about this, I'll explain this later on, but this is if you're going to use open profiles. So what I'm going to do here is I'm going to set my model to unfold using the V width. So I'm going to say that this is going to be bent with a V of 12. So that's the unfold method that I'm going to use. And then I'm going to apply that, and I've created my base component. What I want to do now is add a flange. Again, I'm going to add a flange to the bottom, but I'm going to deliberately put a flange radius of 1 mil in there. 1 mil, which is incorrect for this material thickness. Okay, and then I'm going to add another flange going upwards. And again, I've specified a 1 mil internal bend and that again is incorrect. Now I know it's incorrect because of the color of the bends. Down is red, up is blue, but if it's pale red, that tells me that that is incorrect radius for the V width that I've selected. And the blue indicates, the pale blue indicates that that's an incorrect bend radius. Okay. So if I just go to my annotations and I go into select element and I want to say elements, I'm going to come in here and I'm going to put me a dimension down here like so. So you can see there that that's a 1 mil internal bend rad. Okay. Now, if I come into my sheet metal, I've got this edit bend radius option, and this says apply the radius from the V width. So with that ticked, if I select the bend, you'll see that the color has changed. It's gone from pale red to purple, and the radius is now gone to 2.7 millimeters. So the software is actually calculated the required bend radius from the V width that we've specified. Now, unfortunately, designer can't put that on when we build the model because the actual radius is based off of the material thickness, the material type, the actual angle of the flange, and the V width all combined to calculate that inner radius. So if I specify this bend as well, it says, sorry if I accept that, and then we'll do this one as well. Okay, so that one's gone dark blue, so it's correct, so it's 2.7. If I change my flange angle and I drop this flange back here like so, now again, that is now a pale blue because that's an incorrect bend radius. So if I go in here and I say edit that, apply it from the V, pick the bend, okay, you'll see the bend radius is now 4.0 because I've changed the angle. So that is doing a very accurate calculation on the material thickness, material type, the V width, and the angle of the flange. So that's really why it can only be applied after the fact, because it needs the angle of the flange to know what that calculation is. Okay. Right, we'll look more at applying various unfolding methods as we go through, but I now want to move on. So we're now going to look very quickly at how we can create a component from an open profile. So let's have a very quick look at that. So again, I'm going to go to a brand new designer session. I'm going to select a work plane that I want to work on, and I'm going to view that square on. And then in my wireframe, I'm going to draw a very simple shape. And we'll do something like this. So we'll start here. We're going to say 30 up 100. We'll come over, let me zoom out a little bit, come across here, come across to 100. And then I want to draw this down to the same height. So in Designer, I can simply snap to an existing point and then drag across. And so that's the same height. And I'm going to put a dimension of 30 millimeters in there. So that's all I've done. And I've now got an isometric view of that. If I go to my sheet metal and I say create a part, you'll see that that distance that was grayed out before is now available to me. So I can say I want this to be 300. And then if I window around those elements, that's now created a sheet metal bracket of 300 mil long. And I can make that longer if I wish. And I can change the thickness whilst I'm here as well. So I can just simply drag this thickness up. Again, you can type this thickness if you wish. So we've created a sheet metal bracket. I'll make it slightly thicker so you can see. And then we can accept that. So there is my sheet metal bracket based off of a simple wireframe profile. Now the profile's still there. You can see here, there's the profile I drew. So it's got sharp corners. The software has automatically put bends in at the correct radius for that material. Now again, I say correct radius, they're showing pale pink and pale blue because they're incorrect. So what I'm going to do is I'm going to specify that I want to change those. Now, what you can do is you can use Smart Select and you can select all bends and have them all updated to the correct bend radius, like so. So we've now updated those bends to the correct bend radius based on the V size that I've selected for unfolding. And then if I come in here, I can unfold this. Now you'll see that it's actually unfolding vertical. I don't like that. What I want it to do is unfold flat. So when you set your part properties, what you can do is you can pick a face, any one of these faces that you want to be the up face when it's unfolded. So I'm going to pick this face here. And so now when I go into my sheet metal and I say unfold, there's my develop blank unfolded. Right, whilst I've got this model up, I want to add a flange. So I'm going to come into my add a flange option and I'm going to pick this edge here. Now, just going to do this so that you can see the various positional choices we have for our sheet metal flanges. So here I am looking square on the end of my component. At the moment, I'm going to change my bend radius so you can see it a bit easier. So there's my flange added onto the side of my component, and I'm using the full bend outside. So in effect, the start of the bend starts at the edge of the material. If I was to say the inside constant, then what it's doing, it's keeping the inside face parallel or level, collinear with the outside of my part. If I say outside constant, then it's brought the whole bend in so that this face is collinear with this face. So those are the three options you have for positioning this flange. So if I go outside constant, and I want to reduce the size of this flange by 5 mil either end. So I'm just going to shorten this flange. And if I do that, you'll see that it's pulled that flange in, but it's automatically put some bend relief in here. Now the width of that bend relief is related to the material thickness. So in this case, the material is 3. So that bend relief is 3 in there. And I've added my flange. So if we did something similar over the other side, we can do that. But if we wanted to, we could change the position of that flange and have that one sat on the outside. So we now have those two flanges added. If I then say that what I want to do is just unfold this so we can see our development, you can see there are the two bend reliefs required because that flange starts inside the material. There's no bend relief required on this side because the full bend was outside the edge of my original part. Okay. Okay, so what I want to do here just very quickly is show you how I can add a non-rectangular flange. So I'm going to come in here and I'm going to place a work plane on there and we'll say accept that and we'll look at that from a plan view. And then what I want to do is in my wireframe, I'm going to snap onto here and I'm just going to draw a line here and we'll do one here. And then I'm going to just draw a very simple curve as the description of my flange. Okay, so if we accept that, we have our flange in there. So we can draw a non-rectangular flange by using simple geometry. And then what we can do is we can add that by adding a tab to our flange. I'll show you that in a bit more detail as we go through, but I'm conscious that time is running away with me, so I've got to move on. So we have, okay, this one, a lot of people will be using Designer really to fix or repair imported models. And this is a step file that was received from a customer. As you can see from this, it's not a sheet metal item. So let's show you how we would handle this in Designer. So what I want to do is I'm going to import a step file. So here you can see I've got something called Wall Tray 2, and it's a step file. So I'm just going to double click on that, and that will, sorry, let me just come out of here, and we'll start a new session, I think. And then we will bring in my wall tray. So let's have a quick look around this before we go any further. You can see that we've got sharp corners. Okay, so there are no bends. There are no splits in the corner. Okay, this is supposed to be sheet metal, but it doesn't look like sheet metal. We've even got a form on top here, which we need to get rid of if we're going to turn this into sheet metal. So there's a couple of ways we can do this. In our sheet metal tab, we've got something called remove faces. So what we can do is we can select multiple faces to remove. It's a little bit intricate. So what we can do is we can come in here and we can select that. And then we'll do the same from underneath. We can do that, 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 and that. Okay. So if we did something like that and said that we wanted to get rid of that, we've now deleted those elements off of the model. So Designer is very good at sorting out geometry. So although that was one piece, we've been able to remove that. Okay, so now we want to start making this look a bit more like a sheet metal component. So I'm going to start by adding some corner relief. Okay, so here I can simply select on 3 faces and I've added a corner in there, and I'll do the same here. Okay, now when you see the dotted lines, that means I'm still editing this. So what I can do is I can actually change the size of this corner relief. Okay, when it's got the blue dotted lines, but once I accept that, that's now fixed. So we'll come back here and we'll do another one on this corner, and then we'll do one here, accept, and then finally we'll do one here, accept. Okay, so we now have corner relief on all corners. Right, now what we want to do very quickly is add a tear or a split edge. So if we come in here, we say multi-select, we want to split this edge, this edge, this edge, and this one. And again, with the dotted detail there, you can see that I'm still able to edit this. So I can change the size of my gap by simply either typing a dimension or just clicking on the up and down arrow here. So there are my split edges. What I want to do now is split a face. Oh, sorry, I forgot to put my corner relief in that corner. So I'm going to come back here and I'm going to say I want corner relief there, there, and there. So I've now got corner relief in there. So I'm going to now split a face. So if I point to where I want the split to be, I've now got a split face across there. And then the same here, I can say across here like so, and I've split that face. All that's left to do now is to add some bends. So let me just get a nice view of this. So if we come in here and we say we want to add a bend, what we can do is we can say select all edges, and it will find all edges that will accept a bend. There's the bends being added. If I zoom in here, you can see that like so. And then what we can do is we can come in here we can set our material properties. We can pick our up face, and then we can ask the system to unfold. Oh, sorry, let me just undo that. Okay, I forgot to put a bend in here. In fact, I didn't put any bends in because I didn't accept it, did I? So basically, if I go to add a bend and I say all edges, I've got to accept that to make sure that those are in. So now if I unfold that, you can see that there is my model with my corner reliefs and ready to go. Now, what I'm going to very quickly do is I'm going to send this part to RADAN. I'm going to call it, let's put it in TMP. I'll call it okay. So we've now started RADAN. We're going to take this part. So a few moments ago, it was a step file. I've brought it in. I've tidied it up. I can now tell the system where I want this part to reside. I can just put it in my temp directory for now, and then I'm going to import that. So I'm now into the RADAN nester. I've got this part here. If I want to create a nest of these components, I can simply do something like that, and I've got me a nest of components. And if I was to add some tooling to that, I could very quickly create a laser program to actually cut these out. So that's how quick it is going from an imported step file to a finished nest and program. Now, if I come back here, I put some basic corner relief on here, but Designer Sheet Metal will allow you to manipulate your corner relief. So I want to put circular corner relief. So if I select there, I've now got a circular corner relief. I can change the size of this by simply adjusting it. I can also change the position of it. So you can see here, I'm actually moving this corner relief to a different location. So you can accurately position where that circular corner relief is going to sit on your part. So if I accept that, now there's a little trick here in terms of 3 bends coming together. Okay, so what I'm going to do is I'm going to remove some elements. Sorry, yes, let's just do that. Let's go Sheet Metal, unfold, and then come back. So I'm going to remove some faces, and then we'll just do that. There we go. So what I want to do is, sorry, no, let's just take those elements out there. So I've removed the split line and the corner relief off of that corner. And it keeps showing up my, take that one away. Okay. So what I want to do is take that one out the way, and I'm going to add my circular corner relief in here. So I could do that by simply coming in and saying add circular corner relief, and I want to pick this bend and this bend. Okay, and then because it's 3 bends, I have to do it a second time. So I'm going to accept that one, and then I'm going to add circular corner relief, and I'm going to do this bend and this bend. And so we've now added circular corner relief. So we've got a proper circle corner relief there. All I've got to do now is return the split face. So in order to unfold this. So if I go to split face and I pick from there to there, I now have my split face back again. So I've added my circular corner relief on 3 bends. So it's a bit of a workaround at this stage. For it works perfectly fine on 2 bends. On 3 bends, it's just a double operation, and we've now added that in. So we can now come back to our unfold, and you can see that we've got our unfold with a circular corner relief there, circular corner relief there. I'll just do one other whilst I'm here. So if I just fold that back up, and then what I'll do is I will come in here and I will remove a face like so. And then what I can do is I can go into Sheet Metal and I can add a watertight corner relief. Okay, so let me just remove those again. Again, I forgot to accept. So we're going to remove those faces like so. Okay, accept that. And then what I want to do is come in here and add a watertight corner. And I can do that by doing something like that. So there is my watertight corner. So in effect, no corner relief. So if we go to the development of this one, you'll see that in that corner, we have our watertight corner relief. We have our circular corner relief, and that's the one that I offset. And then we've got our circular corner relief on our three bends. Okay. Couple of other things that you can do here. I mean, if we wanted to manipulate this, we could actually go in and we could move a component. So if we did that, if we say we want to move adjacent faces, and we did something like that, we're actually sliding that obrand around along that shape. So again, bearing in mind that this was an imported component, if I unselect this now, I can actually change the size of that obrand and manipulate that to a new location. Okay. And then finally on this model, if we wanted to come in here, we could actually remove some holes. So we could simply, if we didn't want those holes in that face, then what we could do is we could say remove face. And then we could say we want to remove that face like so. And we could do something similar for this one as well. So we've simply taken those holes out. And then we've got our holes removed. And then finally, we'll go to our unfold and we'll see our final unfold. So that was importing a step file, non-sheet metal step file, and then manipulating into something that we can manufacture. And you saw how quickly I could get to my nest in my RADAN. Right, let's see what else we've got to show you. I'm conscious time is really moving on. Oh yeah, I'll just have a quick look at this one. This is an imported file again. So we've got a conical bend here. So let's have a quick look at how we can unfold this one. So again, I'm going to go to a new designer session. I'm going to open up this one. Okay, so we've got something like this. In fact, let me do that from an imported file. So if we come in here and we say there's a conical bend step. So we'll take the step file just to show you that there's no trickery. So that's an imported step file. So the first thing you're going to do is straightforward, set your part properties. So pick a face that you want to be up. Set your unfold method. So you could go, in this case, to a neutral axis value. Okay, and we can accept that. Now the bend, the conical bend has been determined and is colored yellow, so we know it's there. We can then go to our sheet metal unfold, and there is our development of that shape, like so. Now what I'm going to do whilst I'm here, I'm going to go into wireframe and I'm going to go into an ellipse. And what I want to do is maybe put that ellipse somewhere between there, and we can maybe drag this out, change the size of our ellipse. If we're happy with that, we can go back to our sheet metal and we can say cut flange. And I'm going to cut that flange using that ellipse. And if I go back to my sheet metal and I fold it back up again, you can see that we've now cut that ellipse in a conical bend on the flat. So you can position it whilst flat. You can then cut it and fold it back up, giving you a shape that looks something along the lines of this. So that was bringing in a step file and doing a cut on a conical bend. Right. I'm going to show you one other thing because, as I say, I am running out of time. My apologies if you've got other things to do. I could quite have easily filled half a day, if not a whole day, on designer sheet metal. There's so much in it, and there's so many ways in which you can fix broken models. And I wanted to show you all of those, but just didn't have the time. So what I'm going to do here is I'm going to show you how I can create a component from solids. So I'm going to go into simple cuboid, and I'm going to select my cuboid here. And we're going to drag it out, and we're going to say we want it to be 300 by 200. And then I'm going to drop the thickness down. So we're going to come down, say, 75. So there's a simple cuboid. I'm going to do another one on top of here. So we'll just pick that like so. And then we're going to make this one 350 tab 250. Now, this next is important. I'm going to come up here, and the thickness of this is the thickness of my metal. So I want this to be 3 millimeters. So by doing that, I've actually put those two items in the right place. I'm just going to Boolean them together to make them one single solid. So I want that to be Boolean to that. Okay, so we've just now got one solid. So what we want to do now is to do an offset here. Just make sure that I have just got, no, I've still got two solids. I didn't do my Boolean correct. So I want to do a Boolean unite that and that and say yes. Right, so let's have a quick look. Yes, so we've now got a single solid. So that's the important thing, really. Once you've now got that as a single solid, I'm going to use an offset, a shell offset. So I'm going to pick this item. Now, remember I said that that top flange was 3 mil, and that's the thickness of my material. So what I want is for the shell to be 3 mil, and I want the open face to be the top face. So what we're going to do is we've picked the solid, we're going to shell, we want that face to be open, and then we're going to accept. So we've now created a shape that looks like that. Now, again, still a million miles away from sheet metal, but the rest now is very easy. As we did before, I'm simply going to add some corner relief. So I'm going to do that by simply picking 3 faces and adding the corner relief like so. And then there's my corner relief. I'm going to split the corners. So we're going to come in here and we're going to say that what we want to do is split the edges. So if I go to multi-select, I can split, sorry, we'll do it on single edge. 1, 2, 3, 4. So we split the edges, and we need to split the face at the top. So we're going to go split face. Oh, doesn't help if you forget to accept. So we're going to go 1, 2, 3, 4, and then accept. So we're going to split the top face. And again, it's a case of simply picking the point and accepting. Sorry, let's do that again. Doesn't like that. Okay. Just bear with. I think. Not sure why it won't split that face. Let me just try this again. So we wanted something that was 300 by 200 by 50. And then I can do it properly this time, because if I add the cuboid here, I can ensure that it's actually united when I put it on. So we're going to drag this one out, and we want that to be 350 tab 250, and we want it to be a material thickness. Okay. So we should have something that looks not quite like that. Right, okay. So we've created our cuboid. We then want to create an offset. Again, as I said to you, the offset has to be the same as the material thickness. We're doing a shell 3 mil thick, and we're going to pick this face to remove. Okay, and then we're going to put some corner relief in here. We're going to do that by I'm going to increase the size of this slightly, give me a slightly bigger corner relief. 1, 2, 3, accept. 1, 2, 3. We're going to accept that. Going to come around here, accept that, and then like so. Okay, and then we need to specify a split edge. Again, if I multi-select, I can do 1, 2, 3, 4, and accept. And there's my split edge, and then the split face. That's better. That's what I anticipated to see last time, and I'm not quite sure why it didn't put it in, but anyway, we're going to do 1 on each corner, and then finally here to here, accept. We now need to add some bends in. So again, if we come into add a bend, and we say all edges, we get all edges in there, and we accept, and we've now got bends in. So what we can now do is very quickly specify our up face, and then we're going to unfold, and there's my develop blank. So my apologies for the false start, but basically the idea there was to show you building a solid from, building a sheet metal part from solids. Right, let's see what else we've got to show you. Oh yes, I've still got lots to show you. My apologies, I'm just dragging this out a bit. So let's again go to a new session. We don't want that, and I'm going to again import a component. What have we got here? Let's see what we've got. Let's take this one. It's a step file. So we're going to double click on the step file. We're going to import the step file. So there is my step file, sheet metal step file. First thing I'm going to do straight away is add sheet metal properties here and accept. Okay. Now I'm getting this error message straight away, and you can see it says the part unfolded but with problems. So already the software is worked out that there's an issue with this part, and it's highlighted in red the flanges that are the problem. Now, in that state, it doesn't look like a problem. However, when we go to the unfold state, you will see that those flanges actually intersect, making the unfold impossible. Okay, so nice feature, very easy to see where the problem lies, and in this case, very easy to fix, because all I'm going to do is come in here and I'm going to add a chamfer on this corner here. So if I come down here, if I go to single edge, we'll put 100 mil chamfer there. We'll pick a second one here like so, and we'll accept. Okay, so if we accept those chamfers and we come to our unfold, it says, there you go, sorry, it was there. Oh, you can see I didn't quite do enough. It should have been slightly bigger than 100. So what we can do here, we can show off how it is easy in Designer to simply do a move. I'm just simply going to move that face, and I'm going to move it, move it in that direction, and then accept that. Now I really need to do it symmetrically, but it doesn't matter for this instance. So if I now unfold that, we should see that we now have a developed blank that is absolutely fine. And it was picked up by Designer when we brought it in and gave it material properties. It immediately knew that it couldn't unfold because there was a collide, but it's now shown that to me and we've sorted it out. Okay, I'm going to rush through these last two examples because I'm conscious I'm already overrun. I see there's still a lot of you on, which is good. It means you must be interested or you've fallen asleep. But anyway, we're going to look now at making an assembly. So in this case, I'm going to make a very simple assembly. So let's come in here and we're going to draw something very simple to make an assembly. Because Designer works equally well with single parts or multiple parts. So I'm just going to highlight this one. He says I want to snap onto there. And then we're going to do something like so. So we've got our basic top hat section. We're going to then create a sheet metal part from that top hat section. And we're going to do something like that. We'll then add a flange to the end. So as we did before, we're going to add a flange. We're going to pick that edge and we'll make it the full outside and accept. And then the same this side and accept. And then what we'll do is we will put some fillet rads on the corners. We'll do that one there. Maybe we'll make that 12. Sorry, to make that 12. And then we'll do a couple more. Sorry. And we'll pick that edge. Okay, so we have a very simple component. Okay, I'm going to put a few holes in here. So we're going to go to solids. We're going to add some holes. We want to do a drilled hole, and we're going to pick it by that face there, and we're going to pick it off the center of that one. And we'll say, let's do, sorry, that one, we'll pick a few more locations, that one, like so, and we'll accept. And then we'll do some this side as well, just for good measure. So we're going to pick the face. We're going to say that what we want to do is pick it off of there and there. Okay, so there's my first component. I can, if I want at this stage, just unfold so you can see the develop blank, like so. Now I'm going to create a second part in my assembly. So again, in wireframe, I'm simply going to draw a rectangle, and I'm going to do it off of this face. Let's just put something like that down. There you go. And then if we come in here and we say we want to pick, oh, sorry, let's drag this back here and we'll pick that one. So I'm going to do it off of, sorry, 2 points, not the center of the corner. Right, so if we just come up here and we do something like that, and we then simply create a part from that, and we accept. So what we have now, if I undo that, if I thicken it the other way, so if I create me a sheet metal part by simply highlighting that and we'll toggle the thickness this way, we now have a second sheet metal part. If I then add a flange to that sheet metal part and we do something like that, we can drag it out here, and then we can add another flange coming down here like so. And we'll take that offset off of there, and we'll bring this up like that. So there's my second sheet metal part. Now, if I want to add some holes into this, I can simply add the holes and reference the existing holes. But what I want to do is actually move this flange this direction, so that what we can do is we can actually snap it into here so that it is fitting. Now, again, we could obviously maybe reduce that slightly so that we've got a bit of tolerance in there, and accept. So we've got two components. We want to add some holes in the second component. So we can do that by simply coming in here, and we'll say we want to put some holes in. Pick the face, and we want to reference off of existing geometry, so we can do that. So we can use the existing holes to position our new holes. Okay, and sorry. Let's do this properly. Holes, we want holes on this face. We want a drilled hole, and we want it based off of there, like so. And there is our hole related to our first part. So that is a very simple sheet metal assembly. If I decide I want to come here and maybe do a translate on that part, I can simply lift that part up so you can actually see that it is two parts. And then if I go to my sheet metal and I decide to unfold, I've got two parts that unfold independently of one another. If I set the part properties of my second part so that it unfolds flat in that direction, then when we unfold, we get two components like so. So finally, just to show you that you can do more complicated items than that, I'm going to come in here and I'm going to open up this model just to show you something with a few more components. So I have a sheet metal assembly. If we go into the layers, or you can see that we've got various different components, and you can simply switch the visibility of those off so you can see these components in isolation. you can, if you wish, manipulate these parts as we did before and move them. And in fact, let's do a stretch on here. So let's come in here. So we're looking at that, and this is again, I think, one of the real powerful features of Designer is that I've got a sheet metal assembly there, and what I want to do is actually move or stretch the whole assembly, and all I need to do is do something like that, and then I can simply drag those parts. So I've stretched all of the parts that were included in my window, and I've made that entire assembly longer. If I then come in here and say that I want to unfold those items, I can simply unfold all of the sheet metal items in one hit. So that's all of my developed blanks in 3D. Obviously a little bit difficult to see what's going on. So what you could do is you could simply switch off some of these elements, and then we could unfold just the ones that we're interested in. And then we could do a sheet metal unfold on those. In fact, we're going to see all of them anyway. Again, if I put all of these back on, I can actually take the entire assembly to RADAN for nesting. So if I send these parts to CAM, it's going to say, where do you want those to go? We'll save those out. It will start my RADAN up, and every single item in that assembly will be sent through to the nester so that we can actually nest all of them. So here are all the parts it's brought through. I can say that I want 5 of those assemblies. We tell it where we want these parts to reside on my disk. I'm just going to put these in my temp directory, and then we're going to import all of those. So that could have been an imported assembly. It could have been an assembly designed inside Designer itself, but we've now got all of those elements in my nester ready to produce. I won't nest it because I'm conscious I've totally overrun. Okay, if there are any questions.